hope you had learned about the powerful technique of recursion. I hope you remember search algorithm that you had studied previously in your previous weeks, namely the binary search. Let me give you a very quick overview of what it does. It is basically how we search for something in a dictionary or in a telephone directory, something like that. Why did I take dictionary or telephone directory? Because the words or the contents in the directory are sorted, or that is they are arranged in some ascending order, they are arranged in the alphabetical order. So that is why we can apply this technique. So binary search basically calls for a sorted list. You want a list that is arranged in some specific order, either ascending or descending. It calls for a list arranged in this order, and in that list you want to see whether a particular number is present in the list or not, or whether a particular item is present in the list or not. So what would you do? You would check the middle of the list. If that is your required item, you are done. Else you check if it is less than your required number or greater than your required number. Accordingly, you will branch on to the left half of the list or the right half of the list. So this is how your binary search works. You had seen the iterative version of binary search in your previous weeks, I guess. So that is easier, but still an easier thing. Like how I had given you an intuitive version of binary search, like you have to scan into the left half, you have to scan into the right half, something like that. I had given you an intuitive version. So such an intuitive thing can be easily translated into code when you use this technique of recursion. So let us see how we can use recursion to simplify the process of writing code for binary search. Let me say, I'll define binary search. Define binary search. For this I need list, or I can call it list L. I need a list L, some element X which we want to find. You were processing it using the index values. You would have seen that till now, you may be familiar, but still I am just giving you a very quick recap. Indexes in computers starts from 0. Humans start counting from 1, but computers start counting from 0. So the counting starts from 0. So if your list has 5 elements, the counting would be done as 0, 1, 2, 3, 4. 0th element, first element, second element, third element, fourth element. This is how your computer counts. So you have to give the starting index and the ending index. These are required for your binary search, right? So initially your starting index is 0, ending index is actual end of your list. So that is the entire list. Then as you scan the middle element, you keep discarding one half of the list and just keep searching in the other half. So that time it will change. So these are the things you need to do binary search. You need a list, you need the element X which you want to search, you need a start and end index of the list where you want to search. That is, you won't search the entire list all the time. You will search parts of list by discarding the unnecessary half. This is how your binary search works, right? So we needed these 4 parameters. Okay, let me define. As I had said, recursion requires base case. What is the base case? When we have only one element left in our list. If just one element is left in our list, then we have to see that particular element. If that is the required element, then you say yes, the element has been found, else you say the element is not found. Okay, so for element not found, I am going to return a value -1. I am going to assume that my list has all positive values and -1 is not the value in my list. Also, I am going to return the position of the element. I am not going to return the element. Even if you have negative elements, I don't mind, that's fine. I am going to return the binary search. Basically here I am going to return the position in which the element is present at the list. So that is what I am going to return. So position starts from 0, right? So if the element is not found, I will return -1. That is, the element is found somewhere outside the list. That's what basically I mean. So I'll return -1 in case if it is not found. So the base case is one element, just one element in the list. That is the base case. So if there is just one element in the list, how would your start and end be? They would be equal. Start and end will be the same value because there is only one element, that is the start as well as that is the end. So I'll check it using the start and end indices. If start is equal to end, I would check if L of start or end, you can use anything interchangeably because they both are equal in this case. If that is equal to your required element X, you return the start value, that is return that position. Else there is just one element. Say suppose assume you have just one element 10 in your list and what you want to search is 50. 50 is not present in the list and it is having only one element. Then you have to say element not found. For that, I said the code I'm going to use, the encoding I'm going to use is -1. So I'll return -1 there. Element 50 is present in the -1th position, meaning that it is not present. Okay. So I'll return -1 in that case. Okay, this is the base case. If the base case is not true, then else. That means there are more elements in the list. In that case, you have to find the middle element and you have to discard the unnecessary half and search through the required half. You have to split the array into halves and search through the required half. That is what you have to do, right? So divide the array into halves. This thing we have to do. For that, we need to find the mid position. Mid position is nothing but start plus end. So I have to put a bracket because I need to calculate the sum first, then I have to divide by 2. That is, it is the midpoint, right? This is intuitive. Start and so here will be your start and here will be your end. The midpoint will be start plus end by 2. This will be your midpoint. When you divide, there is a possibility that you can get some value that is a floating point value, maybe 7 by 2, 3.5. What is the meaning for position 3.5? Either you have to take it to 3 or to 4. So for that, we are using a functionality int. So we are typecasting it to integer because position is a integer. We want it in an integer, that is first position, second position, third position. This is what we want. We don't want 3.5th position. So we'll use int. So it will have its own conversion. It will either take it to 3.5 to 3 or 4. Maybe we can run here and check. Int of 3.5. Let me give 3. So it is taking the floor functionality. Floor is nothing but the integer that is closest to it. That is the greatest value of the integer that is closest to it. If you take the number line, 3.5 is somewhere here, 3 is here and 4 is here. It is going to the left side. So int functionality is going to the left side and taking the greatest integer. 2, 1, everything is present in the left, but the greatest in the left, the integer is 3. So 3 is returned as the answer. So that will be taken here. Let me start a new console better because for this program we need a new console. Okay. So this is the midpoint we have computed. We have to check if the mid element is the required element. So if L of mid is equal to X, that is the case. We are done. We have found the element. Return the mid element. Else I have to check if it is greater or less. So I would say L of mid is greater than X. Means you have a sorted list and the middle element is greater than your required element. So where should you search? Definitely your element will not be in the right half. You can discard the right half and you need to search the left half. So your array would now shrink from the starting position to mid -1. So mid position didn't have the element. Also there is no chance that it will be after mid. So it will be before mid. So we need to shrink the array up till mid -1 position. It is one position before the mid. Up till that we need to shrink the array. So that is, we'll do it as return the result of binary search on the same list for the same element x. The start position is not changed. See, because we have to check the left half of the array. So the start position is the same, but the end position is not the previous end position. Previously we had a bigger list. We want to split it. So the end is mid -1. Why mid -1? Because at mid position we had checked. Mid position didn't contain the element x. So and x is a smaller value. That is, x is L of mid is greater than x, meaning that x is less than L of mid. So x being less than the mid value will be present in the left half. So from starting position till one position before mid, whatever is the array left, search in that array and return the answer is what we mean. See, it is really very intuitive. See, this is the left half. This is the left half. Then using of iterative method, recursion is easy. You can translate your intuition into code very easily if you use the recursive ideology. Okay, so this is the recursive way to call the left half of the array. Call the procedure on the left half of the array. Search the left half. Else you have to search the right half. So for the right half, end value is the same, but the starting point is different, right? We had searched up till mid. We didn't find it at the position mid, and the value x is greater than the mid value. So it would be present from anywhere from one position after mid up till the actual end point, right? So your start value will change. So I would say return binary search result on L x mid +1 and end. The modified starting point is mid +1. Till mid position we had checked there was no element. That is why we are checking the part after the midpoint. Here we are checking the part after the midpoint. Here we are checking the part before the midpoint. That is the left half and the right half. Whatever we had it intuitively in our mind, we are translating into code very easily. So this is the power of recursion. So it would recursively keep computing and you will get the answer. So you can take any example. I had given you an example of how recursion works in the factorial screencast. Similar to that, you take a list, you try applying binary search on it, you try how recursion works. You would have understood how recursion works. So this particular search, the bigger list, depends on the value of searching on the smaller list. So whatever the result you get after searching on smaller list will be translated back and will be returned as the result for searching on a bigger list. This is how your binary search works in the recursive manner. So we had defined binary search. Now we have to use it, right? So let me give a random list. You can also change it with your version. You can ask the user to input how many numbers he want to input. You input that many number of numbers, or till he presses some key you keep getting inputs. You can by now I guess you all are familiar with the various conditional constructs. So using that you can modify the code as you wish. Now my motto is to demonstrate binary search, so I would just give a smaller list: 20, 45, 60, 70, 90. So this is my list I have given. Please note that I have given the list in the sorted order. If it is not sorted, you have to apply sorting first. Then after you get the sorted list, you have to pass the sorted list to the binary search. Binary search expects a sorted list. So that is very important. Please make a note of it. So this is my list and I will input the X value from the user. Okay. Let me input the value of X from the user and I have to typecast the inputs in my Mac machine, so I am typecasting. You please follow as per your machine's dependency. Input, enter, search key, I would say. But that is what number you want to search. I would input the search key from the user. That is my X. So binary search will return the index, right? So let me store it as index is equal to binary search on the list L, search key X. Starting position is always 0 for the bigger list. Initially we start with the entire list 0 and the end position is 0 to length minus 1. This is a 5 element list, so it will be 4. So let me generalize it. Let me say length of L. This will give the length of the list, that is how many elements are present in the list, will be returned by this length of the list minus 1. This is the ending index. So you initially start off your search with this particular index. This is the, suppose my search key is 80. This will be the entire list will be passed. So it would find the mid value 60. It is 80 is greater than 60. So this half is not needed. This is neglected and this particular thing will be executed. And 70, 90. This will be my new list. In this list, I will search for my key 70 and 90. This will be taken as a mid value as we have seen. That floor value is taken. So this will be taken as mid value. 80 is still greater than 70. So it will skip to the right half. So here there is only one element 90. So this case would be executed. 90 is not equal to 80. So it will return minus 1. So I will come to know that this thing is not present. So there's something like that it works. You can trace through it. I hope you are now clear with how recursion works and you are clear with the binary search concept too. So you can understand it. All that you need is take a pen and paper and trace through how some examples work. That is what is required. With that you can easily understand the concept. Okay, so it will return the index where the element is present in the list. Okay, so I have got the index. So if I just say the index, it is not enough for a normal user. For us, element 60 is present at the third position. If I say 2, they'll say what is this? The computer doesn't know even this. So we have to translate it into a human friendly format, right? So basically what is that we have to do? We have to add 1. 1 is represented as 0. The index in second position is index 1. Third position is index 2. So basically whatever is the index it returns, add 1 to it and display it to the user. And if it returns minus 1, you should not say it is present at index 0. You should say that the element is not found. You should print the appropriate message. So first we will give a check that if index is equal to minus 1. In that case, you should print X value not found. Okay, X value is not found. Okay, else you should print, that is minus 1 is not the case, then you should print that X value is found at position index plus 1. The computer's counting system and the human's counting system differ by 1. So that's why we are adding 1 and displaying. Okay. So this is how you have done. So let me save the code. I hope you are clear with it. We have a list, we input a search key. This you can even modify it to getting the input for the list elements from the user. You have to sort the list. Please note that you have to send a sorted list for binary search to occur. So you have to sort that list, input a search key, then you apply binary search on it. How it works? If there is just one element in the list, it will check if that element is the required element X. If it is the case, it will return the index, else it will return -1. So whenever the element is not found, it will return -1. That is how we have encoded it. In case if the list has more than one element, what it does is it will find the mid element, and based on the mid element, since the array is sorted, it will discard one of the halves. If the element required is exactly the mid element, we are done. If it is less than the mid element, you have to search the left half. So it will discard the right half. It will search only the left half. If it is greater, you have to search only the right half. It will discard the left half. So for this, to understand really well, I would suggest that you take a 20 element list basically, and you try tracing it on a paper. Basically this to understand this clearly, you should work out a lot on paper and less on computers. Computers can do this in fraction of second, but for humans to understand this strategy, it requires some practice. So please take a pen and paper, take some 20 element list randomly, you sort it. Maybe for that you can use a computer as well, because sorting a 20 element list may take some time. So you can use a computer as well. You sort it, you take this, or you take a sorted list of 20 elements. You randomly give some search element. You give some element which is present in the list, as well as some element which is not present in the list. Try to understand how the various runs of the programs are, and you will really understand the process very easily after practice. All that is needed is practice. Please do practice, practice, practice. That's it. Okay, now let us run this program. Let me run it. Okay, it is asking me to enter a search key. Let me enter 80 not found. Perfect. Okay, now let me enter 90. Let me enter 90. 90 is found at position 5. Perfect. You got it? Maybe when I entered 80 is not found in this list, so it says 80 not found. And when I enter 90 is found here. It is found at position 5, so it says 90 is found at position 5. So it works. I would recommend that please you take some pen and paper and work through various examples, work through a list with large elements as well. Here just that I wanted to demonstrate the recursion technique, I had taken a smaller list, an already sorted list. You try different things. Unsorted list, you sort it, then apply binary search. A huge list, a list where you get somewhere if it is a 20 element list, try to find the 6th, 7th element, try to find the 18th element, try to find something exactly near middle or near the middle, something like that. You try various possibilities, you will understand actually what is the logic of binary search, how it works. All that is needed is practice with pen and paper. Keep practicing. Thanks for watching. Have a nice day.